Hello guys, I'm Alukosha Enoch. Welcome to my math tutorial class on calculus. In today's section, I'll be working on rate of change, turning points, quadratic and cubic graph. However, taking a look at this question, it's quite demanding. I will not be able to complete this assessment task at this time. So I will need to take you through some board work, or my board work better still on calculus. So guys, let's get started with calculus. Okay, so I'm going to take you guys through this board work on calculus, so that you have a very good understanding of rate of change, differentiation, turning points, and we'll be able to complete that assessment task accordingly. Okay, so the content you'll be considering today's section is some rate of change and differentiation and turning points. So if you look at this graph shows a distance. This is a distance time graph of a car over a period of 5 seconds. And if you look at the distance, is also a meter, and this is 40 meter. Okay. The gradient of the graph gives the rate at which the distance changes with time. Okay, and the gradient shows the speed of the car. So rate change in distance divided by change in time and give you the distance. Okay, so that is change in distance divided by change in time, and that is also known as gradient. Gradient is also known as slope. Okay, the slope of this very graph. So that will give you what distance over time, that is speed time graph. So that will give you speed, rather not speed time graph. This is distance time graph. So and the slope on that distance time graph give you speed. Okay, so then how do you find the if you are very good, you guys should have knowledge of straight line graph before now. So the change, okay, this slope here is change in y, that is y2 minus y1 and divided by x2 minus x1. Okay, so and you can also rewrite it as change in y divided by change in x. So delta y, change in y, small change in y divided by change in x. Okay, so in calculus, this slope, this change in y is also known as dy, and I'm going to work more on this over the x for now. Let's just take it like that. Okay, so and if you look at change in y now, this is your y2. I shouldn't have, it's okay anyway. So this is your y2, this is change in y, that is you have, if you tag this point here, y2 is a boundary point and this is your y1. Okay, and your x2, your x2 to 0 0 and your x1 is 5. So you have eventually you have a 40 minus 0 and divided by 5 minus 0. So and that is 40 over 5, and we are going to complete accordingly. So let me just use my, that's how we come about 40 over 5, and that is 8 meter per second. So in this example, the gradient is the same as at every point on the graph, showing that the car is traveling at a constant speed. So when you have a straight line graph, then the slope is the same. If I like, I can take this point and this point, so at any point on the slope the gradient is the same. Okay, so what would the distance graph look like for a car that is accelerating? Okay, so if it's accelerating now, definitely this is that time graph. You have to differentiate the first time, then second time, so it's going to be a kind of curve. So as the speed of the car increases, the gradient of the car also increases. Okay, so this makes the graph curve, and the rate of change varies at different points along the curve. So to find the speed at a time, at a given time, find the gradient at of the curve at that point by looking at the tangent to the curve. So and the gradient varies accordingly. I'm going to show you in next slide. Okay, so meaning that the gradient at this point is not the same thing at this point, is not the same thing, like when you have a straight line, that the gradient is the same at any point on the line graph, but this one, the gradient is not the same, so the gradient varies along the curve. Okay, so we can, this one in physics known as instantaneous. Okay, so instantaneous speed, because you can find the speed at that instance, but if it is a line graph, then it's a constant speed. Okay, so let me show you what I'm trying to say now. If you look at this curve now, okay, so the gradient of curve at the point is given by the gradient of the tangent at that point. So the gradient is the line that touches that point and is moving in the same direction as the curve. So look at how the gradient changes along the curve. Now I'm going to vary this gradient now. If I move this straight line, this tangent to the curve, you see that the gradient will change. Here now I have 0.6. I want to move it from this point to this point here now. See what is going to happen. So if you see now, the gradient is minus 0.1. So as I move this, the gradient changes accordingly. Do you see? The gradient is changing. So gradient varies along the curve. Unlike where, so it is at an instant. Okay. So that's that. Let me go to the next slide. So suppose you want to find the gradient of a curve y equals to x squared at the point 3 comma 9. So at this point now, I want to apply calculus knowledge. Okay, even though I'm going to work more on that, but let me quickly introduce you to that now. So guys, calculus differentiation shouldn't be a new topic for you before you can application of calculus in quadratic cubic graph. That's what we are taking a look at. So you should have a good knowledge of differentiation. Okay, so now the first thing now, if you want to find the gradient at point 3, yeah, then the first thing for you to do is to differentiate y with respect to x. To differentiate y with respect to x, say dy over the x. So don't forget, I'm going to take you through this later. So that will be 2x. I'll take you through this, don't worry. Okay, then what you now do is you substitute the x value here. So the x value is 3. So when x equals to 3, then you have 2 times 3 and it should be 6. So let me take you through the board work. So even though here we use graph, and I'm not going to do this, okay, because we want to see application of gradients. So now let's start differentiation now. So the gradient function. So if the gradient of a curve y equals to x squared could be calculated at every point and plotted on a graph, what would the gradient function look like? So let's press start to look at that. Okay, don't forget that I told you before now that you can vary this the points or along the curve. Okay, so now when x equals to 5 here, so when you differentiate this function, we have 2x, then you substitute x equals to minus 5 here, then the answer will be minus 10. So at this point, the gradient is minus 10 when x equals to minus 5. What about when x equals to 0 there? So when x equals to 0, you differentiate, you have 2, then 2 into 0, that will give you 0. What about when x equals to 5? When x equals to 5, then you have 2 times 5, that is 10. But the first thing you have to do is to differentiate. So I will still take you through that later, okay? So the equation of the gradient of a curve is called the derivative of the equation of the curve. So the derivative of y with respect to x is written as dy over the x, d letter d. So dy over the x. So beta is small change in y and divided by small change in x. And the derivative of f of x with respect to x is often written as f prime of x. So example, you have this curve now, okay? When you differentiate y to respect to x, you bring these two back. Now that is 2x, and then you now substitute the value of 3 here. So you differentiate, you have 2x, and when x equals to 3, that is 2 times 3, and your gradient or slope equals to 6. Okay, so can you spot the pattern and use it to complete the table? Yes, sir. What is going on here now? If you differentiate this one, the coefficient comes back, okay, and this one goes to 0. So the coefficient come back, take away 1 from this one, that is 2x. Take away 1 from the power, then the coefficient come back. Okay, the coefficient come back 4, that is 3, x raised to 3, then take away 1. So 4 comes back, then take away 1, 4x raised to 3. So this will be 5x raised to power 4. And this will be 6x raised to power 5. So you see that the power reduces by 1, and the coefficient goes to the back. So generally, if y equals to x raised to power n, then the derivative with respect to s is given by, you bring the n back, then you take away 1 from the power. So that is nxn minus 1. So the process of finding the derivative is called differentiation. So what do you think the derivative of y equals to 3x squared is? So when you bring these two back, that will be 6x, then take away 1. So that is 6x raised to power 1. Okay, that is 6x. Okay, so if y equals to afx, if y equals to af of x, then dy x equals to af prime of x. Okay, what's gradient of line y equals to 5? Okay, that's parallel. So the gradient is 0 because the line is horizontal. And suppose we have a function of the form y equals to c, where c is a constant number. This corresponds to a horizontal line through the point 0, comma c. Okay, so I'll take you through that again. So when you want to differentiate a constant, then it gives you 0. So take any real number, differentiate any real number, gradient equals to 0. Okay. So find the gradient of the curve y equals to 3x raised to power 4. So and if you look at this, what type of function is this? That's a polynomial. Okay. So the first thing is to differentiate this function. So you find the y, change the y over changing x, or better still the y over the x. So and how do you differentiate a function with respect to x? You bring the power back. So 4 times 3. So that is 12, 12x. then you take away 1 from the power, from the original power, that is 3. Then the next thing is to substitute the value of x, because in coordinate system you have this is x and this is y. So substitute the value of the coefficient of x when x equals to -2 into your function. So then you have what? 12 into 2 raised power minus 3. So what is 2 raised power minus 3? That is -8. Then you go ahead and do 12 times -8. So I want to use my calculator to complete that now. So 12 times -8 gives me what? -96. So the answer is -96. So the gradient of the curve 3x raised power 4 at this point is -96. Okay, so let me take you through the board work so that you see that's what I did now. Okay. Okay, now this one here says that match the function to their derivative. So I want to match the function to the derivative now. This power of 5, I'll bring 5 back. So that is 5 times 0.2. So what is 5 times 0.2? 5 times 0.2 gives me what? 1. Okay, so and you take away 1 from this power. So that is 4. So this gives this. Then this one, the power here is 1. 1 times 3 is 3. So 1 minus 1 is 0. Any real number raised power 0 apart from 0 is 1. So 3 times 1 is 3. So the answer of this one is this. So this one, when you bring 2 back, that is 2 times 3 over 2, and that is 3. So 3x, take 1 from here, that will be 3x. So this one match to this. And finally, I don't need to waste my time with this one. So let me just show you anyway. So here you have 4. We multiply 2 here, that will be 8. Then take away 1. So this match to this. Okay. So and that's that. So let's go to the next question. So we have to differentiate this function with respect to x. So to do this, we just differentiate the respective respective term in the equation. So we have how many terms here? We have 4 terms. It's quadratic. Okay, but based on power, it is polynomial. Okay. So you differentiate the first one, which is, so you bring 4 back, so that will be 4x3. Take away 1, then plus, bring 2 back, so that will be 6x. Okay, minus, bring 1 back, that is 5. Take away 1. Then when you differentiate, the constant is 0. So this is the answer. Okay, so let me take you through the board work now. So and that's what we have there. So differentiate each one and you have that. Guys, this is a video you can pause. So because of our time, I need to complete that task we have there. So you can pause and rewind so that you understand what we are doing here. Okay. So the same thing here. Let me also solve this one. Then I will take you through the board work. Guys, we have a lot of questions to complete. I need to be very fast. So now here we were told that the gradient is 15. So and if you are given a function, how do you find gradient? Gradient simply means that dy dx, that is differentiate the function, and the function, the gradient is given to be 15. So what I'm going to do now is to differentiate this function so that we get the gradient and it will be equivalent to 15. So when you differentiate this one, you have 8x minus 1. So since this is the differentiation, that is dy dx, so and this is dy dx, which is gradient, so you equate it to 15. Okay, so from here now I have 8x equals to 15 plus 1, that is 16. So x equals to 2. No, but these guys, we are asked to find the point. So to find the point means that we have to find the coordinates x comma y, but that is just the value of x. I still need the value of y. So what do I do now? The next thing is to substitute this value here into the original equation. So substitute the value of x in the original equation. Okay, so when x equals to 2, the function y will give you what? So then y will be what? 4. Anyway, I see x, I'll put 2x squared. Okay, minus 2. Okay, minus 5. So what I have there is 4 times 4, and that is 16. Because 2 squared is 4. So 16 minus 2, that is 14. 14 minus 5, and that is 9. So the answer here should be 9. So we should have 2 comma 9 as for the point, the coordinates. Okay, guys, 16 minus 2 minus, so that's that. So let me take you through the board work. So and that's what we have there, and that's the answer. So guys, this video you can pause and make sure you understand it. And you can also plot the graph. I'm going to do that now. And guys, I already made a video how to plot the graph using transformation etc. So you just go to my YouTube. Immediately after the class, I will show you. I already show you how to use this formula already. Okay, guys. I'm not going to waste much time here. So now, let me just quickly tell you what is going on here. So now we can also the formula for differentiating powers of x is applicable for all real numbers. Okay. So now if you have 2 divided by x, you can split it the same thing as 2 times 1 over x. Okay, and 1 over x is same thing as 2 raised power x raised power minus 1. So the same application. So bring minus 1 here, that gives you minus 2. Take away minus 1 here, that is minus 2. And that is the solution you have there. So let's just try this one, okay? So don't forget that square root means that that the letter is raised to the power of half. So this means this is equivalent to 4x. Square root of x means x raised to power half. Cube root of x means raised to power 1 over 3 in indices, guys. Okay, so now this is the function I have here now, so I can differentiate. To differentiate, you are going to bring the power back. So half times 4 will give me 2x. Then half take away 1. So that is minus half. So if you want to write it, it's okay like this. You can leave it like this, or better still. Don't forget that this same thing as square root. So same thing as 2. Okay. This means this same thing as 1 over. Okay. So this same thing as okay, let me just put square root first. You know where the square root is from this one. Okay. Then raised to a minus 1 means that 1 over. Okay. So let me just leave it like this first. So your final answer should give you what? 2 divided by root x. Or you can leave it here. It's okay like this too. The examiner is going to give you, but my board will complete it like this. And this is what is going on here. You have 2 times 1 over square root of x. Okay, and that will give you what I have there. That will give you this one here. So let me take you through the board work now. And that's what we have there. So guys, let me quickly go back. This video anyway, you can pause and start. So this time around, I'm not going to waste much time. I just want to show the solution to the following exercise. Guys, this is video, just check and make sure that you get it. And that's that. Okay, how will you find the velocity of an object from a graph of displacement time graph? You differentiate. Okay, so velocity is change in distance over time, so it is given by the gradient. So how can we find the velocity of an object from a function for the displacement and with the respective time? So the derivative of function give the velocity, and that's what we do. Okay, so now here this is if you have a function speed equals to this function here, so you differentiate 2 times 24, that is 48. Take away 1 here, 48t minus 3t raised to power 2. So that's it. Okay, so at an instant, at a given time, you can find that when x equals to 0, you are going to have your value for that. Okay, so let's go to the next question. Guys, because of our time, this one here, the graph show this okay guys, let me just solve this with you. Okay, this question now, let's just do, we want to find acceleration from speed time graph. So how possible is that? So from speed time graph, we anyhow, okay, you can also find from, this is distance time graph. Okay, so we want to find acceleration from distance time graph. The first thing is you can find the speed first. This is not this is distance actually. Okay, so this curve, okay, let me just run through the board work first. So the acceleration of the car at t equals to 2 seconds. Okay, velocity is change in distance over time. This is actually displacement. Okay, you can also change the displacement. The difference between displacement and distance is displacement is a vector quantity y, and distance is a scalar quantity. That is for displacement is in a distance in a specified direction. So when you differentiate first, you have this. Okay, then but we are looking for acceleration, then you have to differentiate the second time. Okay, so differentiate again, that will be 6. Okay, 6t minus 4t. Then when at t equals to 2, then you substitute 2 here, so you have 6 times 2 minus 4, and that's the answer here. Okay, so turning point finally. Okay, so a stationary point occur when gradient of a curve is 0, and the stationary point can be either minimum or maximum. Okay, so when do we have minimum point? We have minimum point when you have a positive graph, and you have maximum point when the graph is a negative graph. Okay, so and don't forget that this is a curve, so you can only have it at an instant. Okay, so the gradient varies at different points along the curve, so unlike when you have a straight line graph. Okay, maximum and minimum stationary point are often called turning point, and because the curve turns at its gradient changes from positive to negative, or from negative to positive. Now guys, I need to tell you some, let me quickly make some notes here that is not in my board work here. So increasing and decreasing function, increasing, okay, function, and decreasing function. Okay, decreasing function. Okay, so I think I will be able to use that to explain also what maximum and minimum function is all about. Now if you look at this, let me use a straight line graph to explain that better. Okay, you know what when you have your look, okay, so when you have, this is a positive graph, and this is a negative graph here, it falls. Okay, this one rises and this falls. Now from point zero, if you look at this point now, if you take a point here, if you take any point here, let me just take, if you take a point here now, so this point is, let's say this is 2 against 4. If you take another point here, and this is 4 against, let's say, 8. So you see that it's increasing. So a positive graph is an increasing function because it starts from minimum and it's going up. Do you understand? So but a decreasing function now, for a decreasing function, let me draw that graph again. Okay, so this is it now. If you take a point here, okay, and you take another point here, so you see that this one now, it drops, decreases, while this one increases. So now for increasing function, if you have an increasing function, when you have a positive graph, then definitely you are going to have a minimum point because you are starting from the minimum. You have this kind of curve. So it's from the minimum, then it goes up like that. Okay, so it has that. But if you have a negative curve like this, so you have a maximum point and it's reducing. Okay, so but I'm going to use my board work to complete that. Or better still, let me just show you something there. If you look at this now, if I bring this curve down, do you see now? So it's positive, and this is decreasing, negative. Okay, so that's that. So how can differentiation help find turning point? So to find turning point in differentiation, you solve that is, find dy dx and you equate it to 0. So find the coordinate of stationary point on the curve with equation. Okay, so let me just solve this one now as one of our application. So this is application in cubic graph. So we have to find the coordinate of stationary points on the curve with equation, or with this equation. Now stationary point, the first thing is to find dy dx, that is the gradient of the curve. Okay, so don't forget how to differentiate. So there I have 3x squared, okay, minus 12. So at turning point, you create that function. I will not be writing everything because of our time. So at turning point, you create that function to 0. So I have 3x squared minus 12 equals to 0. Okay, then you make x subject of formula. If you make x subject of formula, there you have x squared will be 12 over 3. So 12 over 3, that is 4. Then you divide, then you find the square root, and that is 2 or minus 2. Because when you find square root, you have positive or negative in real number. So because square of minus 2 square will give you 4, and 2 is 4. Okay, so now these are the points now. So now when x equals to 2 now, so we want to find you have to find the coordinates. So when x equals to minus 2, what is y? So when x equals to minus 2, substitute minus 2 into this original equation. I'll just use my calculator to complete that. So there I have minus 2 raised power 3, minus 2 raised power 3, minus 12 into minus 2, minus 12 into minus 2, then plus 7, so and that is 23. So when x equals to minus 2, y equals to 23. And finally, but I still need to do something. Okay, then what about when x equals to 2? When x equals to 2, I have 2 raised power 3, 2 raised power 3 plus okay, minus 12 into 3, okay, then plus 7, and that is minus 21. So when it's 2, then I have minus 21. Now how do you tell the type of stationary point we have? Is it maximum, minimum, or inflection? How do you get to know that? To determine the nature, of stationary point, what you do, let me just use red. To determine the nature, I'm not going to write that, guys, because of our time. To determine the nature of stationary point, what you do is to differentiate the function the second time. So when you differentiate the function the second time, if this square y over this s square is positive, then you conclude that it has a minimum point. But if you differentiate the second time and the square y sorry about that, over the s square is negative, then you have maximum points. When it is positive, you have minimum points, meaning that it is an increasing function. When it is negative, then it means that it has a maximum point, meaning that it is a decreasing function. A positive, okay, then if you differentiate this square y over the x square and it is 0, then it means that it starts an inflection point. Okay, don't forget, increasing function, it's increasing, so increasing function has a minimum point. Okay, because a positive graph, something like this, positive graph, or a graph something with a line curve. But if you have a negative graph, straight line like this or curve like this, okay, it is a decreasing function, and it has a minimum, this has a maximum point. Okay, negative, when it's negative, it has a maximum point, and this one has a minimum point. Okay, so that's that. Okay, so now what I'm going to do now is to differentiate this one more time. Then there I have 6x. Okay, since 6x and that variable, so you need to determine at that given point to determine. So when you differentiate the second time now, here I have this square y over the x square will give me 6x. So when x equals to minus 2, that will be minus 12. So minus 12, meaning that this is a minimum point, sorry, a maximum point, because it's negative. Maximum point, let me just put it there. Maximum point is negative, guys, don't forget. Maximum is negative. But when I put 2 here, I'll get 12. So this is a minimum point here. So this one, when x equals to 2 is a minimum point, when it's minus 2 is a maximum point. So let me take you through the board work now. And at this point, I think I will need to solve my to solve the problem we have there because of our time. Oh, what's going on? Okay, so you differentiate and equate, and I have that. So and that's what okay, so 2 minus 9, and that is that. Okay, the only thing is that my board work did not help you to determine whether it's a minimum or maximum point. But already when you substitute 2 into the function, you already get what up. It's a video, guys. Just go ahead and minimize. So how can you tell whether a turning point is maximum or minimum? So and this I already show you how to tell. Not, you don't need to follow this substitution. Okay, just differentiate 2 times and go ahead and substitute. Okay, and the same thing is applicable here, guys. So at this point, I think I will need to complete that task here. This is a practice exercise for you guys to complete. You can access the board work via my test shop, and that's that. So guys, let's just quickly complete this task, and because of our time, God, I pray I'll be able to complete this task. Okay, so let's take a look at the first question now. So this question says that find the set of value of k for which the line y equals to 2x minus 5 cut the curve y equals to x squared plus kx plus 11 in 2 distinct points. Okay, guys, I need to quickly call your attention to something now. Okay, so the implication of this is that when you have let me quickly take print screen now. We have different nature of quadratic equation. Okay, you can have a distinct point, you can have a real root, and you can have complex roots, and so on and so forth. Guys, just go ahead and get, I'm going to show you how to get the video where I took I did a tutorial on that already. Okay, now here, since it has 2 distinct points, so what we have here, let me just quickly sketch. I don't need to sketch, but just for a better understanding. So let's assume that this is the my Cartesian plane, and this let's say is a positive graph. So it's cut at 2 distinct points here. So we have 2 it's real and equal roots. So it's a real and equal root, and for real and equal root, the function said that we have that is b squared equals to 4ac. Okay, so I'm going to use this equation. This is equation for distinct root. Okay, real and equal, real roots, sorry about that. Okay, distinct points. Okay, now so this is what I'm going to do in 2 distinct points. Okay, so that's that. So don't forget also, it could also be something like this, guys. Let me just use another color, because it need not to be 2 different roots. Okay, so it could be something like this. Okay, but 2 distinct. Okay, well, this means that different root. Okay, not necessarily this one could be equal now. So if you cut here, so x could be -1 and -2, but it's something like this, 2 distinct roots. So I have that. Okay, now so the first thing now is that at the point of intersection, the linear graph will be equal to the quadratic graph. Okay, the curve will be equal to the linear curve at the point of intersection. Meaning I'm going to equate this y's. So when this y linear graph equals to quadratic graph, so by implication now, I'm going to equate my equation x squared plus kx plus 11 will be equals to that function there. That is 2x minus 5. Okay, now so I'll just collect like times now, bring all the x there. So I have x squared plus kx. Okay, now this is plus 2x here. When you bring it back, it becomes minus 2x. Okay, then plus 11, and this is minus 5 there. When you bring minus 5 there, this becomes plus 5, so equals to 0. So here now I have x squared. Guys, I want to factor out plus x is common here, so let me bring x out. Then I have k minus 2. Then 11 plus 5 is 16. Okay, so that's what I have there, equals to 0. So I can now apply my formula now, b squared. Now don't forget, generally you have as squared plus bx plus c. Algebraic, this is algebraic expression for quadratic function. Okay, so and where a is the coefficient also, here this is my a here is based on the equation I have here. My a is 1, my b coefficient of x, so my b is k minus 2, my c is 16. Okay, so let's go ahead and substitute now. So b square, I want to use this formula, b square, that is k minus 2 square. Okay, equals to 4ac. 4 times a is 1, then times c is 11. So there I have k minus 2 square equals to 44. Am I correct? I'm wrong, right? B square equals to 4ac. Okay, my don't mind me. So my c is 16. Well, I don't know why I put 11. You say I wrote like 11. I'm sorry about that. 16. That the way I wrote it, I just got confused. Okay, so 16. So what is 4 times 16? I'm going to use my calculator. 4 times 16 is 64. So what do you have here then? I'm looking for the value of k. So just take square root of both sides. Then I have k square equals to square root of 64. And square root of 64 is plus or minus 8. Plus or minus 8. Okay, so from here now, I have k will be equals to plus 8. When you bring 2 here, that will be plus 2. So that is 8 plus 2, that is 10. Or k equals to, when you have minus 8 here, minus 8 plus 2. Minus 8 plus 2, that is minus 6. So now, so what are the range of value of k? So that is minus 6 and less than k. I need to do that very well. So minus 6 less than, sorry about that. Minus 6 less than k and less or equals to 10. Okay, so that's the range of value. Okay, so find the set of value. So this is the set of value now. So that is for which the curve. Okay, so that is minus, you can start from minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. So that's the range of value anyway. So better still is minus 6 inclusive distinct roots. Okay, okay guys, distinct roots. Okay, is it equals or less? Because it's more of a real root, so it's written less than or less or equals to, so something like this. So like that. Okay, so let's go to the next question now. So this is the final question, I pray, because my time is fast spent, right guys. So the number to guys, let me just quickly read that. The number to the curve. Okay, so the number to the curve y equals to this at point this, call the x-axis at a and y-axis at b, show that the midpoint of the curve lies of the line AB lies on the line 4y equals to x plus 3. So guys, this will be quite demanding if you don't go ahead and watch my video on straight line graph, guys. You just have to go ahead and do that. So how do I start this now, guys? And based on the knowledge you have before now, the first thing we have to do is to, because this is normal to the normal to curve means that the gradient, so we go for the gradient of normal, so meaning that go ahead and differentiate this one. Okay, so that's the first step. So when you differentiate that, then you equate it to 0 as turning point. So what do I have there then? So I have the y and the y over the x. Guys, I will need to be very fast. So differentiate this one, guys. You know how to differentiate already. So that gives what? 3x squared. 3x squared plus 12x minus 34. So at turning point, divide the s equals to 0. So meaning that I'm going to equate this 3 s square, because at turning point equate it to 0. Okay. So at turning point you equate that to 0. So that is 3s squared plus 12x minus 34 equals to 0. Okay. So now guys, but now we are told that at that point, because at point, because this is the normal to the curve. Okay, let me show you again. Say the normal to this curve at this point. So this after differentiation, so we'll be given at point. So like you have don't forget that you can find the gradient of a graph at a given point. So let's say this is the graph of 3s squared plus 12 plus y, and I have touched this gradient. Let me use a line. So this is the line at point s equals to 2. So meaning that you should substitute 2 here. That's what I taught you guys before now. So at this point, at that point, when you can vary it at different points, you have different different gradients. So at point 2, so that's what we're going to do now. So it's not necessarily equal to 0, because we're given at the point. So we don't need to equate it to 0. So now go ahead and find the normal, because this is the equation of the normal. So at the point 2, so that will be 3 into 2 square plus 12 into 2, okay, minus 34. So I'll plug that into my calculator now. So that is 4 times 3 plus 12 times 24 minus 34, and that gives me 3. Let me just do that. 3 into 4, okay, plus 24, okay, minus 34. Plug that into calculator, and that gives me 2k. How possible is that? Okay, let me do that again. So 3 into 4 plus 24 minus 34. Okay, it's correct. So that is 2. Okay, so now, so what's going on now? So since the line is perpendicular to the curve, then we can go ahead and find the equation of the perpendicular line to the curve. Okay, so now we're going to find the equation of the perpendicular to the curve, because if this line 4y, this perpendicular, this one perpendicular, something like that. So go ahead and we are going to find the equation of normal to the curve. So equation of normal to the curve, normal means perpendicular. Okay, don't forget. Just go ahead and download my video on a straight line graph, guys. Okay, so now how do you find the equation of normal to the curve? Since I have my gradient now, the gradient of the curve m1, let me denote that one by m1. The gradient of curve, let the gradient of curve be m1, so and that is 2. So I'm looking for the equation of the gradient of the line perpendicular to this curve. So and since the line and the curve are perpendicular, then you use this rule that says that when you have perpendicular, you have m1 times m2 equals to minus 1. So then I can find the gradient now. So the gradient of perpendicular will now be m2. So m1 is 2 already. So let me just take that one. That is 2m1. Sorry, 2m2, because m1 is 2, equals to minus 1. So the gradient there will be minus 1 over 2. So this is this gradient of perpendicular to the curve now. Let me just put this one in a rectangular box. Since I have the gradient of perpendicular to the curve, then I need the equation too. I have the gradient, then I need the equation. Generally, equation is given by y minus y1 equals to m into x minus x1. X minus x1. Okay, we had the m here is minus 1 over 2. Okay, so now this I'm going to find. Let me go ahead and complete this now. So y minus y1. Okay, now how do I get that now? Because I need to, we are giving this now that at point 2 comma minus 8, this is my y, I have it here. Okay, I have my y to be 8. So that is y minus 8. Y minus 8. So y minus 8 equals to, my m is minus half into, okay, now I have different value for x now, so which I'm good, but let me just find the equation first, into x minus x1. Okay, so at this point I think the best thing, let me just find the general equation first. So if I find the general equation, then I think I should be able to complete it accordingly. Okay. Yeah, that is the best thing for us to do now, because this one now, if you look at this one now, say cut the x-axis at point A. So now the implication of this x-axis at point A, x-axis means that y is 0. So mean that I have value for x here where when y equals to 0, and y-axis at point B. So here I have at point B I have just y-axis, a boundary point. So this is 0 comma y. So don't forget, because both are boundary points. So meaning that at an instant I can move y will be 0 here, then I'll find my x. Then also when x equals to 0, then I'll find my y for this equation. Okay, so now my x1 there, my x1, that is 2. Okay, because I have this one here, because the y is 2, I have y minus y equals m into x minus y1. Okay, x1. So y minus 8, because I'm using this. This is your x and y. Let me just label that for you for a better understanding. This is my x, and this is my y. I want to find the general equation now. So when x equals to 8, that is y1. This is 8 here. Then x equals to 2. So I'm going to substitute this one with 2. So 2. So what do you have there now? So y minus 8 equals to, you can open up, that is minus half x. Minus half x. Okay. And plus 1. Because minus half times minus 2 will give you plus 1. Okay. So at this point, let me just make y subject of formula. So y will give me minus half x. Minus half x. So when you move minus 8 there, plus 9. So let me put this one in square box, in rectangular box too. So that's what I'm going to work with now. Sorry about that, guys. So I have this equation already now. So this is the equation I will be working with now. So then I will now work such that when we have this and when we have this, which I got already. Okay, so now when x equals to, so let me start with this one, or maybe when y equals to 0, then I'll find x. When x equals to 0, I'll find y. So at point B, let's start with at point A. At point A, let me just do at A. At A, I have value for x, but y is 0. So when y equals to 0, then I have minus half x plus 9 equals to 0. So guys, just go ahead and make x subject of formula here. Minus half x will be minus 9. So let me just complete it. Okay, minus half x equals to minus 9. What am I doing? Yeah, when this one equals to 0, yeah, minus half x equals to minus 9. But I wrote the way I put minus half x, for God's sake. Okay, I'm sorry about that. Minus half x, okay, equals to, bring 9 here, 0 plus 9, that's minus 9. So when you cross multiply, so minus x equals to minus 18. So x equals to 18. So when y equals to 0, x equals to 18. So this one here will now become, at this point here, so this one now, I have value for x when y equals to 0. So this is 18 comma 0. 18 comma 0. So do the same thing to here now. At B, x equals to 0. So x equals to 0, then I have y, I'm looking for y now. So y equals to minus half into 0 plus 9. So there you can see that y equals to what? 9. So when y equals to 9. So this one here now, I'm going to write the answer here now. So when x equals to 0, y equals to 9. So I can go ahead and find the midpoint now. So this is my, I can now do my x1, y1. Okay, this is B. So this is x2, y2. And this is A, x1 and y1. So don't forget that midpoint, guys, you have to go ahead. If you don't have a good understanding of straight line graph, guys, please just go ahead. I will show you where to download the video and get the resource. So this is equation. This is how to find the midpoint of a straight line. So y2 y over 2 like that. Okay. So just go ahead and complete it now. So if you do x1 plus x2, that is 18 plus 0. 18 plus 0 is 18. 18 divided by 2 is 9. Then y plus 1, 2. So this is 9 plus 0. So that's 4.5. So this is the coordinate for the midpoint. So is it true that if you substitute this coordinate in this equation, the left hand side will be equal to the right hand side? So let's confirm. So 4 into y. Don't forget this is your x and this is your y. So is it true that 4 into 4.5 will it be equals to x, which is 9, plus 9? So if you look at this, 4 times 4.5 is 18, and 9 plus 9 is 18, so it is equal, so it is proved. So thank you guys. That's a good one. So guys, don't forget, I need to quickly show you this one because of straight line graph. Just go ahead and type this URL, type this URL address in your something to have a better understanding on the equation of straight line, so that you understand it better, and also you can access as many video as possible in maths and ICT. So guys, please don't forget to subscribe to my channel. At this point, I want to access more maths and ICT video on robotic and coding. Just put this URL. You have a lot of video, guys, that you can use to enhance your knowledge in mathematics and ICT. So at this point now, I want to say, guys, do have a great day ahead, and bye bye guys. Bye guys, love you guys, bye.